Hello there! I am Master Rake, and welcome to Science for High School with Merivit Education Center. This series is for m.2, and today we will be learning one of physics wonders, motion. We will be learning about distance and displacement, speed and velocity. And by the end of the lesson, you'll be able to learn the difference between distance and displacement, as well as the relationship between speed and velocity. Are you ready to begin this journey with me? If you are, then come on, let's go.
A physical quantity is a quantity that can be measured. Physical quantities have a numerical magnitude and a unit. We define a physical quantity either by specifying how it is measured or by stating how it is calculated from other measurements. Measurements of physical quantities are expressed in terms of units, which are standardized values. Without standardized units, it would be extremely difficult for scientists to explain, express, and compare measured values in a meaningful way. There are two types of physical quantities, scalar and vector quantities. Scalar quantity in physics is one that can be described by a single element of a number field such as a real number, often accompanied by units of measurement. A scalar is usually said to be a physical quantity that only has magnitudes such as size or length, but no particular direction. Examples of scalar quantities are speed, mass, distance, time, area, volume, density, and temperature. Vector quantity in physics, however, is a quantity that has both magnitude and direction. It is typically represented by an arrow whose direction is the same as that of the quantity, and whose length is proportional to the quantity's magnitude. Although a vector has a magnitude and direction, it does not have position. Now, examples of vector quantities are electric and magnetic fields, acceleration, displacement, velocity, momentum, force torque, and weight.
So, how are we faring so far? Are you still with me? Excellent! We were introduced to the physical quantities in physics a few minutes back. Now it's time for you to learn the difference between displacement and distance. Let's begin.
Distance is a scalar quantity that refers to how much ground an object has covered during its motion. Distance is the total movement of an object without any regard to direction. We can define distance as to how much ground an object has covered despite its starting or ending point. The distance formula is equal to the distance of one location plus the distance of another location. Therefore, the change of d is equal to d1 plus d2. Displacement is the length of the path traveled by an object in a specific direction. The length of this path is measured from the object's initial position to its final position in a straight line. It is a vector quantity. It is also defined to be the change in position of an object, and it can be defined mathematically with the equation. Displacement is equal to the change of x, and is equal also to the final position minus the initial position. X sub f refers to the value of the final position, while x sub naught refers to the value of the initial position. Delta x is the symbol used to represent displacement.
Let's understand the concept of distance and displacement with the help of the following diagram. Let's say we have a boy who is traveling from point A to point C. Now his path of travel brings him from point A to point B, and from point B to point C. Now from point A to point B, The distance there is 4 meters. From point B to point C, the length of the distance is 3 meters. Now the total distance traveled by the boy is 7 meters. Displacement, however, between point A to point C, which is indicated by the black line, is 5 meters. After having known the difference between distance and displacement, let's hop on over to the next concept on our learning objective, which is speed and velocity. Now, calculating speed and velocity is easy after all if you have been listening carefully.
So what is speed again? Speed is a scalar quantity. It just shows how much faster or slower you're going over a period of time. Now, if a fast-moving object has a high speed and covers a relatively large distance in a short amount of time, contrast this to a slow-moving object that has a low speed and covers relatively small amount of distance for the same amount of time. An object with no movement at all has a zero speed. How about average speed? Now, if you sum up and total the entire distance covered by your travel, and then divide it up with the amount of time it cost you to arrive at your destination, you will then get a ratio of distance over time, which translates to your average speed. Velocity is defined as a vector measurement of the rate and direction of motion. Velocity is the speed at which something moves in one direction, like the speed of a car traveling north on a major freeway, and the speed of a rocket launched out into space, can both be measured using velocity. Now, the average velocity of an object is its total displacement divided by the time taken. In other words, it's the rate at which an object changes its position from one place to another. Average velocity is a vector quantity. So how do we define velocity again? Now, since velocity is defined as the rate at which the position changes, this motion results in zero velocity. Now, if a person in motion wishes to maximize their velocity, then that person must make every effort to maximize the amount that they are displaced from their original position. Velocity, after all, is a vector quantity. As such, velocity is direction aware. Average velocity can be defined as the displacement divided by the time, where v is equal to s over t.
All right, let's sum everything up. You've heard what speed is, and you've heard what velocity is, right? Now, speed is just how fast you're traveling without the element of direction. Velocity, on the other hand, will show how fast you're going and the direction of your travel. Now, keep those in mind and never forget them.
Now here are some problems. Let us study and analyze the problems together. Here is problem number 1. Try to recall what you have learned so far and then apply them to the problem at hand. I will give you several minutes to solve the problem, and then we will move the slide forward to reveal the solution. Now, problem number 2 is unlike problem number 1. Kindly study the given problem. Determine what are the givens and analyze what are being asked of you. Can you solve this problem? Ready, set, go.
That ends our lesson on speed, velocity, and displacement for part 1 of motion. Thank you very much for watching. Until next time, always remember, science is cool.